7. You go to 6th after this, and then you go to 5th last.
Okay, nah, I'm good.
Okay, so here are the solutions to all of your state test A.
Oh, we did. I had no idea.
Whoa.
I walked in. We got 15 separate today.
Yep. All right. So this is state test A. If you want to take out your state test A and go through 26 through 50 and kind of see, I'll read them. If you just want to look, so it takes a little less time. 26 was C. 27 is A. 28 is B. 29 is B. 30 was thrown out. And you can't do that one anyway, so no worries at this point. And even if you did know your trig, it's still ugly. I mean ugly. 31 is B. 32 is A. 33 was E. 34 was C. 35 was C. 36 is D. 37 is C. 38 is D. 39 was C. 40 was D. 41 is C. 42 is A. 43 is A. 44 is C. 45 is D. 46 is C. 47 is D. 48 is A. 49 is B. And 50 is A. So tomorrow you're going to have, well, you got this packet. So if you happen to not be here tomorrow, or I don't see you for some weird reason, remember your classwork or your homework for that Friday is to start on that state test B. All right, and there's a good chance I'll probably take that up your first day back. So please have that. And remember, when you're doing the problems, don't do the work on the sheet like you normally do on a test, because at the beginning of the class, if I tell you to hand in your work, you're not going to have your problem to follow me with. Are you with me? So do them on a separate sheet of paper. If you don't know how to do it, leave it blank. But again, if I was grading them, I'm looking for your thoughts and your work on this, not a random guess. Because if I think I could do it with a random guess, of course, that's fine. Like if I can look at it and go, oh, it's sine of 30. I know that's 1/2. That doesn't take any work. But if it's a problem that requires some work and you're just magically right, I'm not interested in seeing if you can guess what. So make sure you show me that process for those 25 questions over the break. And tomorrow we're going to jump and do something different. I'm going to talk to you about modular arithmetic, which is number theory, which should not ever be on these math tests, but they are. And when it is, you have no hope except to know these couple little tricks I'll show you. But it's actually a cool little topic you could take in a graduate class or a math class at a university over the course of a semester. But I have a couple of little tricks, and I can kind of cram 2 weeks into one day and show you how to do some of these modular arithmetic problems that are not difficult, and kind of gives you a free 4 or 5 points or whatever. All right, so hey, any questions on this first test? I am looking for it. Any questions on this 26 through 50? You want to take a look at it? Sorry? 26. Okay, so number 26, right out of the gate. And if it's something that's not worth me talking about, if I'm like, guys, that's above your pay grade right now, we might skip it. Although you can look at my solutions. And sometimes my solutions, guys, are me just playing around. And I've told you before, you guys don't have to have more algebra ability than me or as much as me to be able to do the problems. You just have to have the courage to believe that what you know is enough. Now, if you see a trig problem, what you know is probably not enough. But if you see a log problem, you know everything I know. I gave it all to you. I don't have any secret log rules I've hidden in my pocket. So trust that you know enough and just play around with them. And please do this, look at the key on these and see if you can learn some of these. And if you look down at the key and you're like, dude, I have no idea. Well, then don't worry about it. But see if you can just improve on some of these things. That's how I got better in the early days of doing math team, was looking at solutions. So 26 is something that you can totally do. All right, so check it out. It's asking you, what is 27 raised to the 2x plus 1 power? Make sure I'm recording now. What is 27 raised to the 2x plus 1 power? Now, I don't know what that is unless I can figure out what x is. Well, I do have a little equation over here with x in it. So there's two ways to go about this, and I'll try showing you both, although on my key I only have one. So in case you can't see this from home or whatever, this is 9 to the negative x equals 7. So one way to do it is to actually solve for x. I don't think that's the easiest way, but it is a way. So if I was solving for x, how do I get rid of this 9? I'd have to log base 9 this thing, right? So if I did, I've actually never done it this way, but let's try it. I get negative x equals log base 9 of 7. So x would be what? Negative log base 9 of 7. All right, so if I take that negative log base 9 of 7 and stick it in there for x, this is what I'm looking at. 27 to the 2 times negative log base 9 of 7 plus 1. And that's pretty messy, okay? So my goal would be to try to simplify this into something that makes sense to me. Now, to me, that looks really bad. Now, I think I can get there, but it's not going to be pretty. Now, the first thing I would probably do on something like this is I would probably go, this negative and this 2 could be multiplied together. You with me? And then this negative 2 could be swung up to that 7. Remember that log rule? And then 7 to the, and I could leave it like that if I want, but 7 to the negative 2 power would be what? 1 over 49. So I'm going to rewrite this as log base 9 of 1 over 49 plus a 1. So I've gotten it to there. Now, at this point, you have two options. One, you have to take that 1 and add it to this log, which I can't do right now. But can I add logs if they have the same base? Can I change 1 into a logarithm? What would it be? Log base 9 of 9? Good, if you remember that. It's awesome. So what do I get now when I add these two logs?
Log base 9 of 9 over 49.
Of 9 over 49, because I multiply. So now I have this. So it's a process, but I can get there. Now, what do you think I could do with this 9 and this 27 so that they cancel? Because I can't cancel them unless they're what? The same. Could I do anything with that? This requires a lot of log rules going this way. I could change the 27 into 3 cubed. I could change the 9 into 3 squared. And now I have a power to a power. What do I do with a power to a power? What do I do when I have a power to a power? Multiply. So 3 times this. Okay, that just makes it the 3 out front. Now, what could I do with that 3? Swing it up. And do you remember this is a rule that we don't use much? What can I do with that 2? I can swing it up, but it would have to be a reciprocal. Put it in the denominator. So, or I could move it out to the front and make it a half, because the power comes from the bottom, and then the half would go up there and make that a 3 halves. At that point, what can I do? 3 log 3, and I get 9/49 to to the 3 house power. Now, that's my answer, but it doesn't look like that. So what do you think I need to do with this 2? Make it a square root. And what's the square root of 9/49? 3/7, but it's still raised to the 3rd power. So 27 over 343. Now, in a million years, I would not do that. Because that requires you to know some of your eyebrows are raised. Like, what the heck? That requires you to know every log rule on the planet. Literally, I pulled out almost every log rule I knew. Here's what I did. I don't even know if I used a log. I looked at this and said, you know what? This right here, this 9 to the negative x is 3 squared to the negative x, which is 3 to the negative 2x, right? Which is 3 to the x to the negative 2. So I'm solving for 3 to the x because I see a 3 to the x in here hidden. So how do I get rid of that negative 2 power?
Log.
No. How do I get rid of the negative 2, not get rid of the 3 to the x? How do you get rid of a power? Like, how do you get rid of an x squared?
You square root.
But isn't square rooting it the same thing as 1/2 powering it? So how do I get rid of a negative 2? Negative 1/2 power. So you just canceled that out and found out that 3 to the x was 7 to the negative 1/2, which is what? 1/49. Okay, so you just solved for that. Now, check this out. Does that make sense what I did? And I think it's a little easier to get that out. This is 27, which is 3 cubed to the 2x plus 1, which makes this 3 to the 6x plus 3. Are you following me? Now, isn't that 3 to the 6x times 3 cubed? Think about it. Right? Like basis, I would have added the exponents. That's something we started doing in my ciphering at the beginning of the year, but we didn't do ciphering. So that might be a little new to you. And then isn't this right here the same thing as 3 to the x to the 6th? Think about it. Isn't that the same thing as that? Oh, replace 3 to the x with 1/49. Plug in a 1/49 in there because that's what it's equal. I have made a careless error somewhere. I did. No, I didn't. Yeah, I did. Hold on. -2, -2, and -1/2. Okay, I'm sorry. That's not a -2 power. It's a -1/2 power. This is my mistake. So that means a square root. Positive would be a square root. So this is a square root of 7, sorry, on the bottom. Y'all with me? It wasn't 7 to the -2, which would be 49 on the bottom. It's 7 to the -1/2, which is square root of 7 on the bottom. So I need to have square root of 7 on the bottom. So now, how do I clean that up? What is 6 roots of 7? The same as 7 cubed. And a 3 cubed on the top, which when you do the math is. Either way, there's a lot of algebra. But you can do it without logs, or you can do it with logs. Anyway, give it a shot. What else?
For 27, I just didn't understand what it meant by like AB. Like where do you get AB?
AB is just a way of saying it's a unique solution that's XY. It's the same thing as saying XY.
Oh.
They're just saying it's unique. If they say XY, it could be because the variables are X and Y. That could be a whole system or a whole bunch of different values because X and Y stand for all the values that work in each of these. So they're saying a unique point that satisfies that. So they're basically just saying solve. And then when you solve, find 1/A plus 1/B. So if you look at my work on that, I don't know that I used any tricks. No. So I just solved for, I tried to get rid of the x's by multiplying through by a -4. And then I solved for y, plug the y back in, solve for x. I'm really careful. And then I took both of them and did reciprocals. And when I did the reciprocals and added them together and simplified. That's totally something that you guys can do. Because we've done problems like that. Heck, we did a problem that had 3 variable system, like 1 over a plus 1 over b plus 1 over c. Remember that packet I made you go home and read and then you took a quiz over it? So you've done harder or seen harder problems than that. But don't be intimidated by that. But so what if the x's are on the bottom versus x's on the top? I'm still going to get rid of, I'm going to multiply that by 4, that by 4, that by 4, or maybe a -4, -4, -4. And then I'm going to cancel what cancels, and I'm just going to go about my business. I just have to remember that the y is on the bottom. So to solve, I got to cross multiply or whatever to solve for y. What else? I don't have a ton of time left. We got 14, 15 minutes. 32. So 32 asked, there exist positive integers a, b, and c with no common factor greater than 1, so that is true. Oh, yeah. Okay, so it said, what is a plus b plus c? So at first, this is a great problem where people look at it and they're like, I don't even know what they're asking. Like, it's just blowing my mind. So literally on this problem, I sat down and started just playing. And you'll see me playing here. I said, okay, here's my equation. All right? This is me playing around. What can I do on something like this? Well, I have like bases, so I could probably add these logs, right? But I can't do it until those numbers are gone. So I swung the a up and swung the b up, and now I can add logs by combining it to one log and multiplying. So I did that. And then I got this log problem. And then I said, you know what? The log's kind of in the way. I don't really want the log there. I'm trying to figure out stuff about a, b, and c. So I exponentiated with the 200 to cancel that out and got 5a times 2b equals 200 to the c. And at this point, I started going, oh, wait a minute. Now I'm starting to get something. If this is true, 200 to the c is equal to this. That means this number right here has got to be a bunch of 2's and 5's, and it is. If I factor up 200, there are 3 2's and 2 5's in there, right? 8 times 25. So if you look at it, this means 5a times 2b equals 2 cubed times 5 squared c. And right here it said, go back to the original question. It says no common factor greater than 1. So I said, if there's no common factor greater than 1, I'm going to go ahead and let c be 1. Common factor greater than 1. And I said, if c is 1, then this means that the b value must be equal to 3, because that's how many 2's. If c is 1, the b value must be equal to 3, the a value must be equal to 2, and 2 and 3 and 1 give me 6. So this is me just playing around with the problem, but it's not like I read the question and said, and I was inspired and I knew exactly where to go. I'm just playing around with numbers and trying to see where it leads me. But if you look at it, I really didn't use any extra math that you didn't know, did I? Just kind of playing around with the numbers and seeing what would actually make sense. What else? 38. Yeah, and you haven't learned this. Well, maybe you have. I don't know that you've learned this. 38 said, which of the following functions are one-to-one? Okay, this is probably the easiest question on your test if you know what the definition of one-to-one means. Okay, so you know what the definition of a function is. What's the definition of a function? Something that would pass the vertical line test. Now, that's the check for a function, but the real definition is for each x, there's exactly one y, yada, yada. But it means it passes the vertical line test, right? Now, do you remember us talking about inverses? Do you remember me talking about the horizontal line test? The horizontal line test says if it passes the horizontal line test, then the function actually has an inverse as well. Well, if it passes both, it's one-to-one. So a one-to-one function has to be able to pass the horizontal and the vertical. That's all you got to know. So if I say which of the functions is 1 to 1, well, that didn't pass a vertical. A horizontal. This doesn't pass a horizontal. This doesn't pass a horizontal, but look at this one. It passes every horizontal line test, only hits 1 point, and it passes, at most 1 point, and it passes every vertical line test. And what is E? Is E? Oh yeah, and E did not, it failed the horizontal line test. That makes sense? So if you just remember 1 to 1 means it's going to pass both tests, horizontal and vertical, and those usually are easy questions. Sometimes they're a little harder because they actually did they do that here? Hold on. Oh yeah, you had to know what the graph looks like. So that was probably a little tricky on 38 if you didn't know what all the graphs were. Do y'all remember what absolute value looks like?
Like a triangle? Or a pyramid?
No, it's just a V, the absolute value graph.
Oh, yeah.
You've learned that, right? And you've learned about the 1 over x graph, which was D, and you know about natural log. Now you know about natural log. You don't know about the absolute value of natural log. Absolute value of natural log just means, hey, if I think about absolute value, this is a regular natural log problem. But if the x can never be negative, then even negative values are made positive. I don't know, that might be a stretch for you. But you remember how absolute value takes a line and reflects it this way? Absolute value of x? Well, natural log absolute value of x takes that and reflects it that way. So it's kind of a reflection function. But you definitely know this one. This is the savior here. Because even if you don't know what tangent looks like, and even if you don't know what log looks like, you know what 1 over x looks like. And right there, you know that that passes the horizontals and the verticals. So even if you didn't know the others, bam, you know that one. If you didn't know the definition of 1 to 1, though, that was troublesome. What else?
50. Oh yeah, I forgot to do that.
Yeah, and I don't know, forget might be the right word because I don't know you ever learned it. But if I did teach it, I can show you. Rationalizing a trinomial can be tricky. Sometimes, and I think what you're saying, you think you remember it is, or you don't remember it, is sometimes it's the part, like you remember how a sum of cubes or difference of cubes has when you factor it, is a binomial trinomial? But if that's the case, then these numbers right here, two of them have to be perfect squares. Because if you remember how to factor something like this, you're going to have a squared, b squared, ab. So if you were doing a cube root or square root, by the way, that would be a cube root function, not a square root. They'd be cube roots. But on square roots, this doesn't play out this way. And you'll notice neither of these numbers are perfect squares. So you got to get creative on this. So if that was a cube root, if it was something like this, and that was a 4, and that was a 9, and this was a 6, then maybe something like that would go back to this binomial trinomial. But on square roots, what you do is you just group this and try to write the conjugate of that. So you treat it like a minus b, a plus b. And then you just FOIL the crap, get it on top and bottom. You just FOIL the crap out of it. And what normally happens, and look, it's a mess, right? You get all these terms, but a ton cancels. And sometimes you get lucky like you did here and get down to one term. Most of the time what happens is when you clean it up, you get down to here. But once you're down to here, now you've got a conjugate. Now you can just multiply it again by what? 2 root 6 minus 3. And do it again. But in this case, you really got lucky because all the constants and everything canceled. So all I have to do is multiply the top by root 6 and root 6 to clean it up. That's a rare kind of problem. Vestavia used to love to do problems like this. And they do it here as well sometimes. But that is not something that we've talked about, I don't think. So anybody get this? Yeah, that would be a stretch. Does that make sense, though? You see, most of the time you're seeing problems that just look like this. And you're asked to multiply, and you multiply by root 2 minus root 3. But if you ever have 3 terms, just group one of them and go that minus that. Well, then I'm going to go that plus that on top and bottom. And you'll get there. Might take a couple steps, but you can get there. And it's really not hard. You just got to be really diligent and patient and Try to cut down on careless errors, that kind of stuff. What else? I mean, unless you made 100, you're bound to have a question or two, right? Especially something you tried maybe and then missed. Anyone?
42.
Says find the largest real value of x so that the reciprocal of that is that. How do you write that statement?
1 over x plus 1 equals x minus 1.
Yeah, so 1 over x plus 1 is x minus 1. Well, how do you solve?
Multiplied by x plus 1.
So cross multiply x plus 1. That gives you 1 equals x squared minus 1.
X squared minus 2.
X
Difference of
squared
2 squares.
equals 2.
Difference of 2 squares. Yeah, x.
Well, you could, but if I just add 1 there,
Yeah.
what do I get for x?
Plus and minus 2. And then
Plus
the
or minus root 2?
And then the largest ones.
So the largest real, they're irrational, but they're real, right? There's no i's in there. So the largest one would be the root 2. Who got that?
I got that one.
Good. Guys, we got to get those. Like, that's something I know you know how to do, right? Just don't be intimidated by it. It looks a little ugly. A lot of these things, listen, the algebra is not bad. You just got to trust what you know. Be patient. Read it. You can do a lot of these, a lot more than you think you can. The main goal of me going through these is to help you to realize that confidence is the main barrier. People just get intimidated by these. You're getting bullied. Really. That's what it's about. You're getting bullied by this. I walk into these going, dude, I'm going to own you. That's my mentality when I go and want to take these. Like when you guys take this on the 10th and I get it, I'm going to go through and do the whole thing. Like it's kind of a challenge to me, like, all right, can they beat me? And a lot of times they do. Like if I was taking it in 2 hours, it'd be tough for me to get every problem done because there's always one or two I'm like, that I don't know a trick to and I'm having to figure out the trick. I'm going, if I don't, I'd rather just figure it out with math than know some bogus little rule. Although rules are nice. All right, 3 minutes. Anybody? Anyone? And if you're not here tomorrow, make sure you watch the video on modular arithmetic. It's a good little thing to give a quiz on. It's kind of cool. Number theory is kind of a cool topic in math, I think. But if you're here, which I hope you are, most of you are all pretty good on attendance. But don't forget, test B, I think it's test B. That's what we got over the break. All right.